There's this popular story about quantum mechanics that a lot of students coming into the field have heard.
Okay, let's talk about the wave function, because when we're speaking about the collapse of the wave function, the collapse of something, what is this wave function, and why do you believe that there is none?
That's a great question. So let me say a little bit about some history. I think some history here might be helpful to ground things. But before I do the history, let me first answer your question. I'll give the short answer, and then we'll talk a little bit of history, because otherwise I might get lost in the weeds. There's this popular story about quantum mechanics that a lot of students coming into the field have heard. The first primary object in quantum mechanics is the wave function. It's this mysterious, undulating object. It's a little bit unusual. It's kind of like the electric fields, sort of, except that its values are complex value. They're complex numbers. They're like ordinary real numbers plus a number times the square root of -1. And somehow they're connected with probabilities in some way. And somehow the point of quantum mechanics is wave functions. They're the central player in the story. And how you think about quantum mechanics begins with how you think about wave functions, right? They're the protagonist of this story. There are, I think, some good reasons to be a bit skeptical of that picture. And I don't think that there really is much, there would be much controversy about saying, I think, when you learn about quantum mechanics and you begin to see that there's this much bigger picture, you begin to see that the wave function in this sort of story is a little bit of an oversimplification. I think if you pressed someone who works in physics pretty far, they would admit, actually, this picture is it's a little bit too quick, and there's a deeper picture beneath it. And so I think there's one view in what I'm saying here, your question, which is just to take those concerns and take them to their logical conclusions, right? Ask ourselves, okay, what does this theory really consist of? Is it really about wave functions at all? And for that matter, are wave functions things that describe objects that are really out there in the world? And this is where one lives in kind of a liminal space between physics and philosophy when you ask questions like that. So it's not even clear how to even think about wave functions that live in anything like physical space in the universe as we know it.